creating a factor is always easy. We cannot create an x. I cannot multiply by x and divide by x. That's not possible. But a little factor, a little number, a constant, it's always easy. So now what do is the 4x cubed with a dx, 4x cubed with a dx are all in dy already. So then I have 1 over 4, the integral from, and e to the y, e to y dy. So this is 1/4 e to y plus a constant c. Oh, I'm sorry. Let me start from scratch. Sorry. So we have the integral from x to the third e x to the fourth dx, and we realize that this is what we need. So y equals x to the fourth, but we need a differential. The differential is 4x to the third dx. I have x to the third, I have the x, but I don't have the 4. I can never make up a variable, but I can always make up a number. So multiplying by 4 and dividing by 4 doesn't change anything. But now this and this are in dy. This is here, and 1/4 is in front. So it's almost done. I have to go back and replace y by x to the fourth. So this is 1/4 e x to the fourth plus a constant c. Always remember, I will not assign something that I did not show in class. So you should always review the notes first, no matter what. That's my suggestion. It's up to you. Good. Other questions here? Is this okay? All steps?
Yes, thank you.
Thank you. Anyone else? Other questions on this one or anything else? If there is anything else that you would like me to go back to, explain, etc., 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 anything. Maybe you'd like to choose something else. Or we move on to the definite integrals. We only talked about indefinite integrals with the substitution. Would you like to choose anything else from the indefinite, or we move on? We worked on last time on 42. We worked on 32 or 33 last time as well. With your permission, I move on to a definite, or we still want to practice anything in indefinite? Do not fall behind with your homework, please. It's not a good idea to rush through it the last moment. So can anyone give us some advice? We move on. Are we okay with indefinite or not?
I'm okay to move on if everybody else is.
Okay, well, you can always stop me and go back. So we're going to discuss now the substitution rule for definite integrals. And please understand that this procedure is slightly different. Okay, I'm going to start with, let's say, 47. You'll choose the next. So the integral from 1 to 2 x squared minus 1 to the 7th dx. Please remember one thing. We always have to check that this function is continuous on the given interval. Of course it is, because it's a polynomial function, so it's continuous everywhere. But we always have to check, because here's why. If you ask me to determine the integral from 0 to 4, from 1 over x minus 1 dx, you realize that this function is not defined at 1. 1 is in the interval. So this function is not continuous on 0, 4. all I have to write at this point is FTC, Fundamental Theorem of Calculus, not applicable. Please remember this. Here we did not have to discuss that, or there were some conditions that could be attached. But here it's a must. We cannot apply the fundamental theorem of calculus if the function is not continuous on the given interval. Good. So we are back to our problem. Yes, the function is continuous. I'm going to write it again here. I'm going to copy it here. You don't have to copy it if you have room. So the integral from 1 to 2 from x squared minus 1 to power 7 dx. Can anyone give us an idea what will the substitution be, or what should the substitution be? You can use any letter. I like to use y because it reminds you of dy, but you can use any letter you like. Anything but x, of course. Can anybody give us an idea of what this should the substitution be?
X squared minus 1.
Absolutely. This is it. X squared minus 1. Yes. Perfect. Good. I need to determine dy immediately, without which I cannot continue. Can anyone give us a dy?
2x dx.
2x dx. Excellent. Good. So I have the x and I have the dx, but I don't have the 2. Who cares? Making up a little factor that is a constant, of course. A constant, a coefficient, not a big deal at all. Okay. Now please pay attention. Don't write anything for a moment, please. I have 1/2. I have the integral. Please don't write, just 1 second. 2x dx is the dy. And what do I replace x squared minus 1 to the 7th power by?
Would it be y to the 7?
Indeed. What I'm saying right now, please don't write anything for just 1 more second. Understand that x is between 1 and 2. X is between 1 and 2. I am not allowed to copy the limits of integration for x in an integral with y. I have to find the corresponding limits of integration, meaning when x is 1, what is the lower limit of y? When x is 1, what is the lower limit for y?
Zero.
Excellent. When x is 2, what is the upper limit for y?
Three.
Very good. Do not copy the limits of integration for a variable to another variable. You have to identify, calculate, determine, whatever you want to say, the corresponding limits of integration for y. If x goes from 1 to 2, according to our calculations, y goes from 0 to 3. We're not going backwards to the previous variable in a definite integral ever. So therefore, this is 1/2 y to the 8th over 8 from 0 to 3. So this is 1 over 16 multiplied by 3 to the 8. And this is it. So, of course, we're going to go to the graphing calculator and see what this is, 3 to the 8th power. So 6561 divided by 16. And this is it. So what have we learned? Number one, the technique of finding the substitution is identical. But once I have the substitution, of course I determine the differential because I cannot create an integral with a function without the differential. So everything is accounted for, the 2 and x and dx. 2x and dx right here. This piece is right here. The 1/2 is in front. But now I have to calculate new limits of integration. The limits of integration corresponding to the new variable. So when x is 1, 1 squared minus 1 is 0. When x is 2, 4 minus 1 is 3. We do not go backwards like we did here with the indefinite integral. The indefinite integral is a function, mainly the most general antiderivative, a family of functions as we know. So if the initial variable is x, the final variable has to be x. Not here. We don't care because the answer is a number. If I calculate the integral in x or calculate the integral in y, the number will be the same. So these are the differences between the substitution rule for definite integrals and indefinite integrals. It is a must to create or determine or calculate the corresponding limits of integration for the new variable for which we calculate the integral. Any questions? Okay, now your turn to choose anything you want from the definite integral. Anything from 45 to the next page. So right now, let's choose from here, and then we move on to the next page.
Do one of the fractional ones like 59 or 60.
Very good. 59, very good. The integral from -1 to 0, from x to the third dx, everything divided by 2 minus x to the fourth raised to the 7th power. Good. So we have the definite integral from -1 to 0, from x cubed dx over 2 minus x to the fourth, everything raised to the 7th power. So my first concern is that 2 minus x to the fourth cannot be 0. If it is 0 between -1 and 0, then I will say FTC not applicable. But it's not the case, because x to the fourth equals 2 will have a positive solution. But this is the interval between -1 and 0. So that's not the case. The function is continuous, indeed, on -1, 0. So I can calculate, I can apply the fundamental theorem of calculus. Okay, now we have to decide what is our substitution. The process of finding the substitution is the same. Finding the differential of the substitution is the same. So we are looking at this function. This is our function. And you will say, I think the substitution should be, and it's okay if you're wrong. You saw the pattern, now you have an idea of what the substitution should be.
2 minus x to the fourth.
There is nothing else. Excellent. This piece, because first of all, is raised to the 7th power. And there is nothing I can do there. That is what bothers me. I agree. But we have to find the dy.
-4x to the third dx.
Excellent. Everybody understands this? Thank you, Katie. Everybody understands this? The y and the dy? Now we have to build the new integral, and it has to have new limits of integration. I'm jumping over all this. Good. So now let's see what we have and let's see what we don't have. The constant can be made up. Nothing else can be made up. We have the x to the third and we have the dx. But I don't have the -4. Not a big deal. I multiply by -4 and I divide by -4. So therefore there is a -1/4 in front. Now the integral. Let's account for everything in here, and then we'll decide what the limits of integration are. So I have now the -4 x to the third dx. All this piece is the dy. Clearly the denominator is this y to the 7th. I cannot continue before finding the correct limits of integration. When the lower limit is -1, -1 to the 4th, with minus in front, 2 minus that. What do I get as the lower limit? So remember, x is between -1 and 0. When x is -1, the lower limit. When x is 0, the upper limit. So let's calculate. This is just algebra. When x is -1, how much is y?
Just 1.
Indeed, because -1 to the 4th is 1, with minus in front, -1, 2 minus 1 is 1. Good. Now we have to calculate the upper limit when we plug in 0. That's easy.
Two.
2. Perfect. I know this is very easy. I know how to calculate this. -1/4, y to -7, which becomes y to -6 over -6 from 1 to 2. So remember what I did? I replaced 1 over y to the 7th by y to -7. So when I determine the antiderivative, I copy -1/4. I add 1 to the power, and I divide by the resulting number. This is not finished, but I'm going to wait for you to see let me know if it's okay. Do we understand this? Any questions? Is this okay? So therefore, we continue. This is what I'm going to do. I'm going to put 1 over 24 in front. And then I write 1 over y to the 6th from 1 to 2. 1 over 24 can wait outside patiently. I put in 2. 1 over 2 to the 6th. When I plug in 1, it's 1. You can leave it as is if you want. 1 over 2 to the 6th is 1 over 64 minus 1. You can perform some operations if you want, or just leave it alone. Any questions? Any questions? Okay, so let's go back. Let's see what else you would like to go back to or calculate. Any other definite integral before we look at some word problem or problems?
U56.
Of course. Here it is. 56, very good. 56, we have the integral from 0 to b from me to negative mx dx. Perfect. Very good.